Hey everybody. So if you ever come across one of these older Dell computers that look kind of like this here, this is an older example, but you also have the newer ones from the late 2000s and early 2010s that are in this, I guess we'd call it a BTX tower. I don't think it's actually official BTX tower, but these Dell Dimension systems and similar systems alike, if you had one with, let's say, a Pentium D CPU or a Core 2 Quad CPU, any of the power hungry or space heater type CPUs, you would have one of these nice heat pipe coolers inside. Now if you're unlucky, you had one like this one here, probably, for example, it's got a, I think it's a Pentium 4 CPU. Yeah, Pentium 4 HT. Now, sometimes you will get the nice core, but other times you'll get a piece of crap aluminum one. But a lot of these Dell systems had these really nice heat pipe coolers in them. There's one, for example, right there. I got screws in it, which will explain why that is here shortly. I have two of these. Here's another one. So yeah, I have several of these, and of course the thing is, they're not really, you can't easily mount them into a system because they don't have a really standard mounting pattern like you have, let's say, for example, with most AMD CPUs and Intel systems. But I did come across an interesting find tonight to where we could adapt this cooler to install on an AMD Socket AM4, FM2, or possibly AM5 processor. So I have been looking over this core carefully, and I was about to start getting measurements of it because I was thinking I was going to have to basically 3D model something to adapt this to install to a AMD style motherboard. But I was like, what the heck, let me just look on the internet and see what kind of STLs are out there. My original plan was to start off with, let's say, an STL file for just the standard AM4 retention bracket and make modifications to that using Tinkercad. But I happen to see this right here, this Fantex PH-TC14PE AM4 mounting bracket, and I was like, wait a second, because I looked at this file. And the key thing of importance here is there's this hole here for a screw. Now if you look here at this cooler, you have the two holes there where the screws thread through. It's currently got threads in it. I think it's M3, if I'm not mistaken. So I got some screws in there. And I was thinking, what if I 3D print those and just see if it matches up? So here I dug out one of my spare, or my only spare, AM4 motherboard. And what I did is I 3D printed some test pieces using those STL files. Now these of course are not meant to actually be put into service. They're actually just printed with standard PLA at just 15% infill. This is something I could print in about 20 minutes on my FlashForge Adventure 5M Pro 3D printer. And lo and behold, if you look here, of course I don't have an extra CPU to install on this motherboard, so I made sure this was good and clean. And of course this is the last generation of AMD desktop sockets that don't have the pins on the motherboard. If you look here, look how well those screw holes line up with the screws of this core. What a coincidence! I kid you not, what a coincidence that these brackets just happen to appear to fit perfectly with this OEM Dell heat pipe cooler. So out of curiosity, I decided to actually just go ahead and look up this cooler, this Fantex PH-TC14PE, and let's just say it is a pretty massive cooler, but it's definitely not the same as that Dell OEM heat pipe cooler. Apparently it's just a coincidence that these models off of Thingiverse just happen to be a fit for that Dell OEM heat pipe cooler. Pretty interesting find. So my plan here is to do a CPU cooler upgrade on the Mid-Tower Deluxe. Now, for those who might recall, last year, I think it was last year, I converted this thing back over to air cooling. It had been water cooled for many years, but then the water pump sprung a leak. It actually formed a crack in the plastic on the output fitting. So I was like, you know what, let's just go and go back to air cooling, because, I mean, a lot less to break, and yeah, just the worry of a leak, yeah, that just done it for me. So right now I have this OEM style cooler. I think this is out of an HP system on there, and I mean, it does the job, don't get me wrong, it does a job, but when you're doing more CPU intensive tasks, you will hear that fan ramp up, and I'm like, okay, let's see if we can put a little something different on here. And honestly, I do like heat pipe coolers. I think they are nice. So what we're going to do is we're going to do the experiment on this system. What I'm going to do is I'm going to 3D print a new set of those adapters, this time using some polycarbonate PETG blend filament. You want to use a good rugged filament for this. Anything that's under a bit of tension or strength, you gotta use something that's good and strong, because PLA, I mean, you could probably get by with PLA. However, I don't think PLA long term would be the best option. Maybe ABS, I don't know. Honestly, I like the PETG, the polycarbonate PETG blend for stuff like this. It's good, it's durable, very solid material. So we're going to 3D print a couple of those adapters using 100% infill. Yes, it will use a bit more filament, but it'll be something that's rugged, durable, not nearly as likely to break. So I'm going to walk you through how to 3D print these parts using flash print on a FlashForge Adventure 5M Pro 3D printer. Okay, so I have flash print pulled up. I just reloaded the machine with the polycarbonate PETG blend filament. So this was the slice for these models using PLA. It only took about 19 to 20 minutes to print. So of course, in case you're wondering, this here is what the model looks like. You can see a whole lot of space inside, not really intended for shrink, just for testing purposes. So that being said, let's go ahead and slice a new model. I'm going to go up here and I'm going to select my polycarbonate PETG blend custom profile. Now in flash print, you can get by with the FlashForge PETG, actually, or even the high speed PETG profiles. But what I did here is this custom material, and actually the slice profile, the PETG blend, was I started off with the high speed PETG profile, and I made a few tweaks here and there to try to strengthen up the material a little further. So that being said, let's go ahead and change the infill to 100%. Yes, it will use more filament and it will take more time to complete, but you're going to end up with a very solid model, or a very solid piece that's going to be a lot less likely to break, and you do not want your CPU cooler mounts breaking. So going here to additions, I will enable brim for this, just to ensure we don't have any warping on the edges. So that being said, let's go ahead and slice. And we'll do our, actually this is a preview, so it's still only going to take 30 minutes on this machine. So if you're using a 3D printer and it takes a very long time to print stuff like this, you may want to look into a machine like the FlashForge Adventure 5M Pro. And in case you're wondering about that machine, I do have videos up on the channel of that machine. I highly recommend it. It's been a great 3D printer. So that being said, I'm going to go ahead and send this off. Now I'm going to actually title this differently. So Dell Heat Pipe Cooler AM4 mount. So we'll go ahead and send that off. Now the machine's going to begin printing. So in this case, it's going to take a few minutes for it to get the bed up to proper temp, because the bed has to come up to let me see here. I think it's 95 or 90 degrees Celsius, something like that. It's for PETG and so the polycarbonate PETG blend as well as ABS. They do require very hot bed temperatures. Yeah, no, there we are, 95 degrees Celsius. So it will take a few minutes for this bed on this machine to get up to temp, and then it's going to heat up the hot end to about, I think it's 250. And then once that is done, it will of course print that off, and that'll take about half an hour, which is not bad. Okay, so for those who are curious, this is the print in progress. So we're about 31% into this print, and this one, unlike the last one, is 100% infill. So you're not going to see that, basically that grid that was in the last one, or at least in the model I showed you earlier. So this will be done in about 20 minutes, and then once that's done, we'll be moving on to the next steps. Okay everybody, so here are the completed adapters. These are 3D printed in polycarbonate PETG blend at 100% infill, so they are very sturdy. And it didn't take too long for these to print on my machine. If I flip this over here, you'll see that I have installed an M3 nut, because they have a little spot in the bottom, a little hex in the bottom for the nut to go into place. This is what your M3 screw will thread into. There's a better look at it right there. Other one is the same way. And I've used a little bit of super glue to secure those into place to ensure they don't come out, because we don't want that to happen. Another thing I went ahead and done was, you may recall that these holes in this cooler for the screws, they were threaded. I went ahead and drilled out the threads because we don't want the threads in this, because again we're using the threads in these adapters. So more or less a screw will slide through just like this. You can see it freely goes right through now. And for safety, we're going to be using compression springs. I actually harvested these off of an old laptop cooler, like a really old laptop cooler. That's why they're kind of big. The idea is, when you tighten down a cooler onto your CPU, you want to have compression springs there, so that way when you tighten this down, it's a safeguard to over tightening. Because more or less, when you don't have these springs, more or less your motherboard and your retention bracket act as the compression spring, and you don't want that. I've seen countless times over the years where motherboards will actually get warped due to the tension from the CPU cooler that did not have compression springs. So you want to have these compression springs there, because you don't really need to have a super crazy amount of tension holding this sink down. But you do want to have it on there tight, but not so much that you're breaking things. So that being said, these screws are M3 by I think 30 millimeters in length. These might be a little too long. I don't know for sure. We'll find out when we go to install this. So in the case that they are too long, what I can do is just thread on these little thumb nuts, whatever you want to call them, like thumb screws, except they act as a nut. So those would thread on. I would thread those all the way back, and more or less I could use those to tighten down as needed to prevent this screw from going all the way through and touching the motherboard. So again, that's something we'll have to see when we go to install this. Okay, so now the next challenge is installing a fan. So I got this 92mm fan. This is one I picked out of my collection. It's a Magic 12 volts, of course, 0.32 amps. So it's kind of a moderate speed fan. It's not a very low speed fan. It actually does move some air at full speed, but it's not overly loud. And it uses a 3-pin connection. So my motherboard is already set up to run a 3-pin fan, so that'd be fine. So if you're doing this as well with one of these coolers, I'd suggest getting a 4-pin fan if you don't already have one. That way your motherboard can easily control it if it does not support controlling a 3-pin fan. Now to mount that fan is a little bit of a challenge. There's a few ways you could do it, but the way I prefer to do it is to model up an adapter or a shroud that basically snaps onto this cooler and actually holds the fan. You screw the fan into it and then you attach it to the cooler. So here it is in Tinkercad. That's what I modeled up. Have a look at it here. So more or less the fan gets installed there, and this whole contraption slips over the cooler. Now here's a better look at it in flash print. Actually, this is the slice preview. So we'll go through here and show what it looks like as it 3D prints. Now if I close the preview, we'll get a better look at the actual model. So I'm going to delete the supports, that way we can get a better look at what we actually have here. So more or less this is what we have. I use my caliper to measure everything out, and fingers crossed this will work. I have it 3D printing right now, and it's going to take just under 2 hours or so to print this. So I'm printing this in PLA, and I'm doing it roughly 60% infill. That way it still has some decent strength to it, because we don't want this to break, obviously, but we want it to have some strength and also still remain light and not use too much material. So that being said, once that finishes printing, we'll give this a try. Okay, so here's a look at the fan shroud 3D printing in progress. So we're about a third of the way through this and still have another hour and 14 minutes to go before this is done. So as mentioned earlier, white PLA filament. I was kind of on the fence between white and clear, but I had a lot more white than I had clear. And plus this white filament is starting to get a little aged, where it starts to get a little brittle, so I'm trying to use it up on various things. So going with the old standard white for this one. But yeah, this is, like I say, this is a fast machine. It's, if you're using, like I said, an Ender 3, of course Ender 3s are good machines, but these, they're quite fast. I'll say that for sure. And this thing's been reliable. I haven't hardly had any issues with it. So anyways, I'll let this get done and we'll go from there. Like, there's something else I did want to point out about this cooler is these Dell motherboards that use these coolers, there's something kind of weird about them. They had the CPU offset at a 45-degree angle, so it was more diagonally shaped, and that's why this base is, well, diagonally shaped instead of being square. The concern that I have with some of these is, while the base on these is actually really well finished. I mean, look how shiny that is. You do have these little, I guess they started out as fasteners, I don't know, but they were cut off and of course lapped down to the same level as the base. Now some of these, they might be a little bit raised on there for sure, but that's why it's imperative that we use decent thermal compound, and that's of course why we have thermal paste on a CPU, is because you're going to have imperfections in the mating surface between the cooler and the CPU itself. So that's why we have that thermal paste. And so for example, over here you can see what I was talking about. Right there is where the CPU used to actually attach or get, well, basically this is how the CPU was sitting on this cooler. You can see the little indentation there from thermal compound, and of course now our fan shroud is complete, so I'll have to go take a look at that. So here's the fan shroud. Okay, this is actually kind of thin. Maybe a little thinner than I anticipated. But we shall see if this will hold up. I may have to increase the thickness of this a little bit. Okay, so I've removed all the support material off of this shroud, and this is the test fit, and I'll say that's pretty dang good if you ask me. Now of course there's a little bit of a gap there, which is to be expected. I've made a little provision on the inside of this to account for that. So really the way this is going to work is I'm going to use 2 screws to fasten this to the cooler. They'll screw in through the aluminum between the 2 aluminum sheets. Assume that's aluminum. Might be steel, I don't know. That way it'll hold this in place, and of course before I do that I gotta install the fan on here. But yeah, this is pretty much what it looks like. Not bad. The only thing I would have done different is I would have used 100% infill on this, just to make it a little bit more rigid. So if you are doing one of these, which I will actually include a link in the description to this STL where you can download it. That way if you're wanting to do a similar project like this with one of these exact coolers, you'll have it available. But yeah, not bad. Okay, so I got the fan mounted to the shroud, got the shroud installed to the cooler, and my little method here of using the screws to secure it has worked. It's secured into place, and I got the fan running just to demonstrate noise. Get off to the side here in case the air was messing with the audio, but it's not too loud. The shroud also helps ensure that air comes in through the back. This is kind of how it was when it was an original Dell system, although in the Dell system the fan was in a push configuration. The fan was like back here, it's a big 120mm fan with a shroud that would direct air through this, through the rear, and it would exhaust into the system. Yeah, jetting the nice hot air right into the rest of the system. Yeah, wonderful design. But here we had the fan in a pull configuration. My plan is to install it in the system like this, to where the air is exhausting out toward the back, because I'm not sure if this thing would clear the memory if I had the fan on the other side. So I got the fan mounted on this side, so now it's time to install this thing. Okay, so before I actually swap out the cooler, I figured I would do a brief temperature test with the existing cooler that's in there right now. Again, it's that one that came out of an HP system. Right now everything's sitting idle, and I'm going to pull up Prime 95 and do a brief stress test. I'm going to do in place, maximum heat, and see what happens with the temp here. You're going to hear that fan ramp up in just a moment when I start this. Right now we're sitting in the upper 30s. Now the thing is, these Ryzen processors, they've always seemed to run, at least on the sensor, they always seem to run a little warm. But let's go ahead and start this. You'll see what it goes up to. And here's the fan beginning to ramp up. Now this CPU is actually running at stock clock. Now I'm not going to run this for too long, but we just want to get an idea before we change this out to see if we get any difference. Again, I'm going to leave the exact same fan curve as I have it at right now. So for example, if I go up and look at the main board CPU sensor, it says 61 versus 75 on the package. So I'm going to go ahead and stop it. You know, watch it settle down. Okay, so I got the system unplugged. Now it's going to start by removing the existing CPU cooler, which first I should note, although this system is getting due for a clean out, the CPU cooler is not obstructed, so it was passing air through the heatsink assembly. So we can't blame any high temps on a clogged cooler. Although I was researching online, the Ryzen CPU temps, they do tend to run hotter than some of the older ones, the older CPUs I'm used to. I've always thought the temps on these newer processors, both Intel and AMD, are just, they're hot. Yeah, it used to be hitting 70 degrees Celsius, you was in trouble. But now when they're saying like, oh, 80's okay, 80's okay, you get to 95, then you're in trouble. I'm like, wow, 95 degrees C on an old processor, you was in big trouble. Alright, this, get this off here. I tell you, these clip coolers from AMD, you gotta love them and hate them at the same time. Sometimes they can be a real pain in the butt to get off, but hey, this is way better for my older viewers who used to work with AMD Socket A. You know what I'm talking about. Have the screwdriver slip off of the clip and damage your motherboard. That was always fun. Alright, so we got her off now. Now this thermal paste that was on there is kind of a thinner stuff. I have two different compounds. I have more of a basic compound. Actually, it was originally Radio Shack heatsink compound. It was bought in the days just prior to Radio Shack going under, and it came in these little like flexible tubes, and I transferred it over to a syringe. And I mean, it does okay for the most part. Now for higher performance applications, I have this other stuff in here somewhere from Corsair XTM50. I picked this up, I think, at Best Buy. It's something local, and it's a little bit better quality stuff. We're going to use that on this one. Alright, so just wiping off the thermal paste just for now. We'll go back and clean both the new cooler's mating surface and the CPU with isopropyl alcohol. But what I'll do first is I want to get these brackets off of here. So the idea is we're retaining the mounting plate behind the motherboard, and we're retaining these fasteners, these screws. They're getting transferred as well. We're just changing out to the new 3D printed adapters that were intended for that one cooler, which I forget off the top of my head what it was, but just so happened to also fit this Dell OEM heat pipe cooler. It's like, what are the odds? Alright, so that we do not lose our bracket on the back of the motherboard, we're changing out one set at a time. Now what's crazy was when I went from water cooling to this air cooling setup, I changed everything out exactly the same way as you're seeing right now. But at that point I had to take all 4 screws out to get the water block off. The water block made use of the stock retaining bracket on the rear That was anxious. Trying to be careful to not accidentally lose the back plate, because this old case from 2007 does not have a hole in the back where you can easily access right behind the CPU mounting area of the motherboard. What I should have done first is I should have made sure that these were properly sized, because apparently they are just a little bit undersized because the screw is threading into them. We don't want to thread in, so what I'm going to intentionally do is run these in and strip out any threading, or just use a screw as a drill bit, kind of per se, to wallow this out. That way the screw is actually fastening into the bracket behind the motherboard and not just this. Okay, so I had to drill out the holes in those adapter pieces because I guess the modeler assumed M3 screws instead of M4, which I believe is what these AMD retaining brackets use. So since this model was 100% infilled, I was just able to drill the holes out and make them a little bigger. And for example, it's kind of hard to see here, but this is the size of screw that came with the mounting bracket, the stock mounting brackets for the AMD coolers. And this was all I could find. Yeah, it's quite a bit longer. The one on the left here is I think it's an M4 by 10 millimeter length. This is like a 20 or 25. So yeah, quite a bit longer. Definitely got my anxiety up a little bit because I think these screws are almost bottoming out on the case behind the motherboard as they tighten up, which is not exactly what you want to have, but I made sure that when things were beginning to tighten down, that this didn't still feel loose. This feels good and tight, so it did tighten down. But of course, the person who modeled these STLs did a good job on them, but that's just like a little misstep. Perhaps there's more to the whole situation there as to why those holes were smaller. But I'll have to go look at the license, and if possible, I will go into Tinkercad and open those holes up to M4 size and post it where you can get these, of course, with credit to the original modeler or person who modeled them. But for example, this is what the length of the extended screws is. You don't need them to be that long. Probably, I would say probably a M20 or M15, or excuse me, 15 or 20 millimeter length screw would be sufficient enough. So I'm going to go ahead and take out this bottom bracket. Maybe you'll see there, I still got the bottom stock bracket in there. Got to pull it out so that way I can install the bottom replacement bracket. Alright, that's out of the way. So now that I've drilled these holes out, I'll show you what I was talking about earlier. So this is the side that goes down toward the motherboard, and as you can see, the screw doesn't even make it out the other side of the hole because this is so much thicker than the stock bracket. It needs to be thicker for the added strength, but we need an additional probably 10 millimeters worth of screw. So these were the closest I could find. Alright, let me install this. Like, I begin to feel resistance right as we get to the bottom. Yeah, we are hitting rock bottom there just a little bit with that one. Let me back that one out because I think I had one screw that was just slightly longer than the rest of them. I'll have to go track down another screw that's shorter. Yep, it was longer. Alright, so I need to find one more screw. See how this one does. The thing is, when you feel resistance before it gets all the way down to the bottom, it's because the screw is beginning to press down on the back of the case behind the motherboard, and in turn it's actually pressing against the case, and also could be pushing the motherboard up, and you don't want that. That's not good for the motherboard. Now as a grounding concern, shouldn't be an issue there. Obviously that bracket behind there is insulated from the rest of the motherboard. If anything, it's grounded. Alright, that's better. That's, yep, good and tight. So let me go find one more screw. Okay, I tracked down one more screw. This one actually came off of a Socket 939 or 754 mounting bracket. It's a 20mm long screw. This is really the ideal size for this. So what I'll do is, for you, to make it easier for y'all, I will hunt these either on Amazon or in my affiliate program. That way you can get these if you're doing this as well. If you happen to be lucky enough to have one of these old Dell heat sinks. So go ahead and get that in there. And it, yep, I can see it bottom out right there on the bracket. That's what we want. We didn't want to feel any resistance before it bottomed out. Alright, now the moment of truth. We're going to test fit the cooler. Now this one's going to be a little more tricky. Gotta be careful with this. So make sure I can see the bracket. Make sure that we are not, so for example, have it bottom out on the CPU. Okay, very good. Now let's see. These are kind of long screws, but we'll see what we get here. Yeah, I'll tell you what, I'm killing tonight with misplacing things. Just setting stuff in random spots and then don't know what I've done with it. Have you ever had days like that? Curious, let me know in the comments. Now the thing is, with these 3D prints being, okay, I do still need to have the spring on there. I forgot to stick that on there, but right now I'm just seeing how deep this goes in there to determine if I'm going to need anything to space out. But like I mentioned with the thumb screw nut, whatever you want to call it. So it looks like we only need the compression springs, and I got a couple of rubber washers here. Well, actually they're plastic washers. I was hoping to find some metal washers, but literally just had to go off what I can find. Alright, so now you've got all the rest of the stuff I need. Let's clean up the CPU and this surface and get this installed. Okay, so now we're going to apply some thermal compound to this. I'm going to put a little dot in the center. Now of course there's a big old debate about whether it's better to do the dot in the center or to spread the stuff. I've seen videos where they say spreading is better. They actually do testing to confirm that. I'm gonna apply a little more, probably a little more than it's needed. I don't go too far overboard, but we want to make sure that this thing has adequate coverage. Now, on camera, it probably looks like there's a lot more there than there actually is. It's got to kind of spread it out just a little bit. But anyways, let's go ahead and install this bad boy. I got the screws ready this time with the compression spring as well as the plastic washer. I'm going to start with the upper one first. Now I'm going to go down to the bottom, get it started. Good, it catched. So as I think I might have mentioned earlier, this model, I think the holes for the screws were just wide enough for the screws, so the screws will probably end up making some threads in the plastic material, but also it'll catch and engage with the metal hex nut in the back. Now I'm just going back and forth a little bit at a time. Don't over tighten. In boldface, don't over tighten. Again, that's why we have these compression springs there. Okay, so I think we got her at a decent tension, nothing too crazy. Honestly, I do like the coolers where the screw bottoms out and it literally uses just the tension of the spring. These are a little more tricky. This is kind of like installing my CPU water block, actually. That's what it kind of reminds me of. So I'm going to feed this cable around here and plug it in. So I used the upper connection on this motherboard, this CPU optional, because that's the one that can control the 3-pin fan. Alright, so I'm going to start this thing back up before I even put the side panel back on. Just to make sure I don't have any major issues. Alright, this thing's a little weird how it starts up. Alright. So I have the fan curve set up on this machine to where it actually idles, actually cuts off the fan when the temperature is cool enough. So the fan's actually not even running right now, so I know for sure that we have good thermal contact with the CPU, so that's not a concern there. So we should be good to go. And we're starting back up into Windows, as I see. I actually hibernated this thing, or supposedly hibernated, so hopefully I didn't lose all my stuff. If I did, oh well. Alright, so I'm going to put the side panel back on this thing. Okay, this thing's been around for a little while now. And just look at how massive this cooler is. I mean, that side panel fan, it just barely cleared it. I mean, look how close it is. It's just almost touching it. I mean, just barely cleared it. But, like I said, it's been running for a little while now. Nice and quiet. You can see a fan running there, running on low speed. We're about to do a temperature test on this thing again, see what we get. But yeah, overall, I think this is pretty cool. Again, just look at the massive size of that thing. It's huge. Okay, so right now it's sitting at just a little over 32 degrees Celsius. And we can see our max temp prior with the old cooler. Again, I hibernated the system when I changed out the CPU cooler. I didn't actually shut down Windows, I just hibernated it. So it's still showing our max temp from the previous run. It was 75 degrees Celsius. Alright, let's go ahead and run the torture test again. This time again we're going to do in place FFTs, maximum heat. So here we go. Now I should note that the temperature in the room might be a tad cooler than prior, but you can see there's a huge difference in temperature with this massive cooler. So you hear the fan ramp up a little bit there. So not only does it run cooler, it's quieter, a lot quieter. So I'm feeling back here behind this exhaust fan, and I can feel some heat. Now of course this is mixing in air that's inside the case, but I'd say that's quite an impressive upgrade over what we had prior. I knew this giant cooler would do well. It was just a matter of getting it mounted into this kind of system. But we managed to pull it off using 3D printing and 3D modeling, since I had to model up that fan shroud. But yeah, there we go. Really impressed with this. Definitely a huge upgrade, and was definitely worth all the trouble to do it. Okay, just a moment later we're at 65 degrees Celsius, which is still much cooler than what was getting earlier. So anyways, that's it for this video. Hope you enjoyed it. Thanks for watching.